Nebulae are clouds of gas. Well, gas actually weighs something. People don't think about gas as weighing something, but it does. So one of the experiments we do in the physics class sometimes is we have a container, and we just weigh the container. It weighs something, and then we put the lid on it and put a vacuum pump and suck the air out of it, and then weigh it, and it actually weighs less. So gas really does weigh something. So aircraft, when an aircraft is flying, an airliner, for example, they're pressurized so you don't pass out when you fly too high, but they're not pressurized at sea level or even ground level pressure. They're typically pressurized at about 10,000 feet or 8,000 feet, I guess 8,000 feet elevation. And so they're typically pressurized at that level, which is actually pretty high. And so people that are used to lower elevations sometimes feel a little lightheaded or odd inside the aircraft. And the reason they do that is that less air is lighter, and so literally they can pump thousands of pounds of air out of the aircraft, and it weighs less. That means considerably less fuel, and you notice your ears start popping before the plane even gets off the ground. I mean, on the runway, as it's going down the runway, they're pumping air out, and it's getting lighter, and so air weighs something. Hydrogen weighs something. Doesn't weigh as much as oxygen and nitrogen, but hydrogen weighs something. So what happens is you get a really big nebula out there, and its own gravity is trying to compress it. And so you have this large nebula out here, and this really big nebula out here, then what's happening is gravity is trying to pull inwards on it. Well, what happens to a gas when you squeeze it? It gets hot. When a gas heats up, it tries to expand. Okay, and so what happens is that you end up with this balancing between the gas trying to expand because it's warm and the gravity trying to compress it. And so normally what happens is the outward push wins, but if something is light years across, that's a lot of mass, which means a lot of gravity. And so the two are fighting against each other. Even these things that are light years across with a lot of gravity, if they're hot enough, they're not going to collapse. And so you have this trade-off. How compact is it? The more concentrated it is, the more compact it is, the tighter bunched together it is, the higher the density, the more the gravity wins. So the smaller it is, the more likely it is that gravity is going to win. But the hotter it is, the less likely it is that gravity is going to win. The bigger mass it has, the more likely. So all these things go together, the mass, the density, and the temperature, or the mass and the volume and the density, because density is related to volume. So the mass, volume, temperature, or mass density temperature. They were all worked out mathematically by Sir James Jeans, and so the condition has to be just right for everything to fall together, and we call that the Jeans criterion. So the Jeans criterion, so you have to have enough mass. And so that critical mass we call the Jeans mass. And so it depends on the temperature, depends on R, that's the size, the radius, assuming roughly spherical, okay, and depends on the average mass of all the molecules. 3 and 2 are constants. The capital G's universal constant, universal gravitational constant, and then the K is something called the Boltzmann constant. So the K and the G are constants there, and so basically you have the temperature, which is the T, you have the R, which is the size of it, and those are the main things. Okay. Well, the other thing that we can talk about is the Jeans density. How compact is it going to be? And so the density, and so again, there's something called the Jeans constant, which is a constant he worked out, and it depends on the temperature, depends on the total mass, and depends on the mass per molecule. So again, the temperature, okay, the total mass, and then that determines how small you have to squeeze it in order for it to collapse. Well, that would give you the first sort of thing, and what we have here are blobs of dark gas and dust that are starting to come together to actually collapse. And so they're right at the point of exceeding the Jeans criterion.